Okay, so we're recording. Anybody have anything they want to? Does Juan want to say anything if he has to leave early? Is there anything he wants to add?
No, I'm working. I'm regaining my work in the simulator, as I told before, because I changed my computer to a Lenovo, and I got the Ubuntu 20.04 installed. And this time I leave the dual boot with the Windows with the Windows 10 because of you, as I saw that you have the dual boot. And I think that the next week I will be working in trying to run the simulator, reorder the folders as I got it in the other computer, because I got the bridges to my hard drive from the Docker files, so I can program the launch files and the URD from the VS Code. And as a news, I will be working on Monday with the team of Ross Spanish with the ESP32 port of the NOAA bot and the design of the board that we are building for the components.
When you say the design, are you talking about like big ticket design decisions, like what kind of motors, or are you talking about
that is
3D design?
Yes, it's the 3D design to send the board to print to China, but we are stuck in that part. We were working in it's very similar to the down tractor because all the usually mainly the robots, when you see the Ross robots, are a Raspberry Pi and another board, maybe an Arduino, a Tensi, a ESP32, or a discovery board where you plug all the sensors and communicates to the Raspberry through Ross serial, or in the case of Chef, his personal protocol to do that. And we are trying to declutter the robot installation through a design board where we will put the components that are the step downs and in our case the ESP32, in this case of work, and we have two lines, two main works. One is to port the code from the ESTM32 to ESP32, because the code in the ESTM32 is it's program in the personal application of those ports. That is the ESTM32 IDE. It's different. It's different to an Arduino code that you upload from the Arduino or the platform. You have a lot of things. You have the chip. You have to. It's very different, but not so different. If you are a guy that knows how to move that code to the other platform, I think that won't be much difficult, because it's code. They are not so different, but that's a lot of work.
I mean, I'm what I'm going to put here looks like it's dated 2018, which means it's really, really old, but it has a picture of it. I mean, you're familiar with the Ag Open GPS board, or have you ever seen the Ag Open GPS board?
I'm not sure.
I mean, it's probably been through 3 iterations since this 2018 article, but they did what sounds like you're doing as well, and that is to create a board to, as you said, declutter installing components.
I think that Open GPS. Yes, I have been.
They don't use ROS. I mean, they have what I'll describe as a monolithic system designed by one, really smart guy.
Yes, a French guy. Yes, I know. I have been reading this, but I didn't go on with it because I don't know how to say it. It runs on Windows, I think, a Windows.
Yeah, it's a whole different approach. I mean, and I'm not advocating changing your approach. The only reason I'm mentioning it is because at the physical layer, they did what you're trying to do. They created a board to make the installation easier.
Yes. This is something similar what we are trying to do.
And that's the first URL that I found that had a picture
Yes.
of the board itself. I think they've subsequently commercialized the product and made it a commercial product and charges, I don't know, at one point I saw $8,000 for the product, but that was back when I think I saw 2018 date. That was back when it was still open source. It's just another, what I thought was a really great example of, trying to, as you said, declutter the physical layer.
Yes, I got the experience of the other project that I was working, that I'm working, that is with the weather stations. When you catch up with the right electronic engineer, is something that it's very smooth, because it's not something that is terribly very difficult to solve. But I'm in the process to catch up the right engineer to do that work. And as our option is to do it open source, I'm failing in that task. But now I think that we have some guys that are willing to work.
I haven't seen anybody else try to do what Ag Open GPS has done on a board. Have you, Jeff, by chance?
Not wide scale. Other people will, put things together where they'll make a PC board and plug all the little modules in. Not specifically for controlling a tractor or anything, but yeah, people do that kind of stuff all the time.
Well, I have made, unfortunately, no progress. I watched with great interest, Jeff, your progress, but I'm hoping to get time to spend on the daggone thing this weekend, but we'll see how that goes. So I don't have anything to report other than making a little progress on a place to test my tractor bigger than my current backyard.
And speaking of testing, I have seen a couple of different parks where they're simply wide open, and especially this time of year, there's nobody in the parks because it's starting to get cold out. So I might have several different parks I could test in. And then there's also a parking lot. I used to have the Walmart parking lot because Walmart moved out. I think their taxes were too high, so they moved a couple miles and built a new store. And for several years, that parking lot was completely open. There's just this huge, big open area. And back when we were doing Ross Agriculture, I took my car over there and drove around and made plots of that. But there's another one that was it was a different grocery store that closed down and another grocery store is going to move in, but they have to spend like $1 million to clean up the toxic waste or whatever's there. So they haven't done anything with it. So there is yet another parking lot I could get in, and just just a big open spot that if I wanted to, I could go over there and drive around and hopefully not run into anything. So I'd have an option between that or some of the big like the state park. It's probably a city park or something, but some of them are big enough. They have big open asphalt parking lots. And again, I could probably go somewhere like that and drive around. So I might have lots of options on that. It seems in Minneapolis, like every 2 blocks, they have a little city park that, just a big grassy area with a baseball diamond and, like a basketball court or something. So there's lots of places around I could go.
Sorry, I will have to leave. See you next week.
So,
Okay. I was gonna say I could go back and check the videos, but if he watches the video, he can hear me say he could go back and watch the video. So yeah, I've got various places I might be able to test if I really want to. And another thing, as I drive around, I keep thinking, if you can get your vehicle to drive at a very slow speed, you're going to be better off in the long run, especially in town where if you're out in an open field, it's not that big a deal. But if you're just driving around in your yard or you've got up next to your neighbor's property, the slower you can get it to drive and be able to control it, it seems like the better off you're going to be. So you say go, and it drives, just like at a creep speed driving around. You can see what it's going to do without it, lurching back or lurching forward, or you don't have to jump out of the way, or when you have to start guessing what's it going to do next. It's better off if it just has a very slow top speed to begin with. So you've got time to think about, well, should it be doing that, or do I need to stop it, or whatever. So that's something I was thinking about, that, as you try to do testing, the slower you can get it to run and be controllable, you may have an option where you try to run it slow and it will not control at that speed. So that might be another issue, but so that's something I was gonna consider. And then
I think that's a good point.
And then speaking of not knowing what it's going to do, it might be handy to put something on the vehicle that tells you, it basically says, here's what I'm going to do. And you can get those little round LED rings from like Spark Fun and Adafruit, so it's a round thing like this, and it's got LEDs all the way around it. So you can make a little indicator that you say a ROS node watches your command velocity and says, oh, I'm going to turn this way, I'm going to turn this way. So you can watch that little LED pattern on there, and where it's going to try to turn. And then you could have another one like a bar graph that shows you up and down that says, here's forward velocity or reverse velocity. So by watching those two, you get some idea of what it's about to do. That might be better than just sitting watching it, because otherwise you start it up and it starts moving and you don't know where it's going to go. And then all of a sudden it comes to a stop. You think, well, is it just thinking, or is it stuck, or is it dead? So, things like that might be, start thinking about ways to give you a visual indication of what it's thinking about. Might be handy to have.
That's a great idea.
But I noticed the more I just driving around with the joystick, just driving around in my yard, and you get complacent very quickly. You forget it may take off and you have to go chase it down, or it may just slam into the neighbor's car, which is not a good situation. So, first of all, you become complacent very quickly. And so again, if you keep the top speed down, that takes away one more problem, that it may take off at high speed. You always have the problem that if it wants to, everybody says, oh, well, it's fast, but you can control it in software to keep it going slowly. Well, if your software is broken and it takes off at full speed, you're still screwed. And that's why when I took I had purposely put on a 12 volt to 24 volt up converter to run my motor, because I thought I needed more torque and more speed. Well, then the first day that it ran away from me, and I realized, oh, I'm screwed. If it takes off, I could still chase it down if I was paying attention. I was close to it in the first place. But if it's the type of thing where you're standing in your yard, you drive it all the way to the block and turn around and come back. Well, if it gets all the way down there and decides to jump out in the street and run down the street, well, now you have to go run half a block to track it down and hit the e-stop, assuming the e-stop on your remote control doesn't work. So all those kind of things is something to consider. What are you going to do? And the other point is you become completely complacent. You think, well, it's working just fine. And you don't realize at any point it may do something stupid. And and take off and do something you don't want. So that could be a problem also. So that's just more things to think about. And, you know, as you go out and drive around, you can be thinking about, you know, how you relate to it, and then how you want Ross to run the thing around. So that's just more things, you know, as you're driving around, you're not just collecting data. You can be thinking about, you know, it would be nice if it did this or nice if it did that. So just keep that in mind.
I think that's really good feedback. Actually, on the circle thing, I think I actually have about a 4-inch LED thing that was designed to build an LED clock. That would be perfect for that sort of thing.
Is that got the addressable LEDs on? So you just hook up a couple wires to it, you can talk to all the LEDs, or was it something else?
I've forgotten exactly how. I mean, imagine a 4-inch circle with, I don't know, 32 LEDs scattered around the 360 degrees. I don't remember how you address those 32 LEDs. But that was the sort of thing it was. I mean, the physical layout of it.
You know, the ones I'm thinking about, they've simply taken like the big long LED strips. They took that same concept, they just put it on a board that they're in a circle. So you put power and ground and then one data line, and you just shift all the bits through to turn on whichever LEDs you want. So it's real easy to hook it up. The only other problem is, by the time it tells you it's going to do something, that may not be time for you to react, or it may be too late to see what it's doing. So it might be nice if, when people write planners, they say, okay, it's gonna decide to do this, it's gonna display it to you, and there'll be a little bit of delay before it actually does it. So that might be something else that could be, you know, put in someday, just so I don't know what you'd call that mode. It'd be like the human interface mode, or the I'm going to do this mode. So you just turn that on, it would show you, it says this is what I'm planning to do, and then, you know, wait half a second or so and then actually do that. So it basically says I'm going to start moving, and then half a second later starts driving forward, and then it says I'm going to turn left, and half a second later then it starts turning left. So that might be another way to look at that, as opposed to after the fact is, oh, by the way, I just ran over you. You know, it doesn't do any good to tell you after it's run over you, or after it's hit your car. So that's just more things to consider the order and how to make that stuff work.
There's varying degrees of collateral damage likelihood with one of it's a 40-pound device at 2 meters a second, and the other is if it's a 400-pound device at 2 meters a second.
Yep. So the other things I was doing, let's see, what was it? How do I get?
Yeah, would you mind just talking through your Slack posts? I mean, those are really interesting.
Screen 2. Okay, if you can see this screen here, let me get some stuff out of the way. Can you see my Slack screen?
See useful links, yes.
Okay, come down here to
random.
This is what I did sometime last week, where I loaded up that code from Mat Sadowski, and I should, let's see if in a second, I'll see if I can find that link, and I'll post it to the chat here. So that will show up then in the video. So anyway, I drove around. What was this one here? Well, here's the thing I was talking about before. There used to be a slider scroll bar down at the bottom here, so you could zoom in on that. Now you just seem to have 2 levels. Actually, if we go out all the way, so we start, this is your basic level. You're just looking at the Slack channel. You click on it, and it gives you this box that's less than the full screen, and you got a size there. You can click it one more time. That's the 3 zoom options you have anymore. You don't have the one where you can run the slider bar back and forth and zoom in and zoom out. But it seems to zoom in far enough. You can see the numbers here, and then up at the top where it's got the labels, you can see those. So it is usable, but I was annoyed when they took that away. So anyway, this was from like last week, and let's see, what was I doing here? This is moving baseline EKF. So this is plotting the actual numbers from the GPS, and you can see on the side here, this is that's a latitude number, the 45 point something. That's a latitude value. And in this case, the orange line is the back antenna and the pink line is the front antenna. So as it drives around, you can see the green and the orange are on top of each other, and the pink one, again, on the front of the vehicle as it drives around, the front antenna is leading the back one. So you can actually see it on the plots here. And when you drive in a circle, you can see that as you drive around, the front makes a different diameter circle than the back diameter circle. And this was just simply, this was my first test running that code from Mat Sadowski. And so it shows the two GPS antennas and then this one called GPS filtered. I think is simply the same stuff you would get if you ran that GPS odom.py program. And it's showing that the orange one here is the output where it's converting GPS filtered. Or is this is either directly, no, I believe GPS filtered is actually when the thing is completely done, it will republish the GPS information. So after it's run through the EKF filter, it republishes GPS. And so if you want to use it for something else down the line, I think is why that's there. And that was turned off before I started playing. And I said, yeah, go ahead and publish that. But you can see here, and I could zoom in on that, but no, I can't because they took away my ability to do that. But see down here, you can see the line coming around. The green and the yellow are pretty much on top of each other, saying that the output of the EKF is following following the orange line, which is my back antenna. Now, at that point, I was making no attempt to remap the GPS antenna on top of baselink, which that came later. And here I was just putting out two of my heading values, just so the static heading. The static heading is the one from my dual antenna GPS, and the BNO55 is my heading off the BNO55 IMU. So I just plotted it there, partly because if this were live, I could drag this slider bar back and forth, and these dots will move around on here. And then over here it tells me what the heading was at the same time. So that's just a convenient way in Plot Juggler to be able to find out, when I was right here, what angle was I driving? You come over here and look at the heading, that tells you that. So then the other thing was, this was these are the two output values from the EKF stuff. And if you look here, one of them is called odometry filtered and odometry GPS. So I think the odometry GPS is after it's converted the latitude and longitude into your offset in meters. And I noticed that when I ran this, when I started, it put the 0 point at wherever the vehicle started. So I put it out in my front yard and turned it on, and it decided that's where 0 is going to be. And I think the fact that it wasn't particularly aligned to anything in particular when I started it, I ended up with this weird, see, it's got a weird rotation to it. This should be, technically, this is along here, this is north and south, which would mean this is east and west, and it's got this weird angle to it. I think it's simply because when I started it and my GPS wasn't locked on, it grabbed whatever heading that it was producing at that point. And then when the GPS locks on and jumps up here, now we've got that initial offset that is a problem. But anyway, I ran this to find out just simply what is it going to do. This is the first time I ran it, and it was actually giving me output data, so I was quite pleased with that. And if we zoom in here, so over here, let's see, the filtered and the GPS. So the bluish line is the actual, that's just the GPS converted to offset in meters. And then the purple one, no, actually, I maybe it's the other way around. I think maybe the purple one is right off the GPS, and see it's noisier, and then the bluish line is smoother. So that's probably the output of the EKF filter. And the fact that it drives around, it's got, I think the incoming data, so we can say, well, but is that data really in the GPS? Well, we can find out, come back to this plot, and that would be over in this area, I believe. And right here, you can see the green line, which is the GPS data coming in. So yes, those really are there in the GPS. And by the time it's done, the orange line looks like it's filtered that out somewhat. So anyway, that's what I ran, and I was just noting problems that I have. And one is the fact that it's rotated, and number two, the 00 is not. I didn't have a way to specify the point in my yard that was going to be my reference point, my origin. So that was a couple things I wanted to look at. So then I made some changes, and I was pointing out here that I realized that, oh, I was looking at my Ross topic echo, and I noticed that my base link to GPS transform was not right. It basically said my offset was 0. And I went and looked at it. And turns out I've got the numbers here are stuck in the wrong. I've got the fields swapped. So technically this up here says it should go XYZ and then go roll pitch yaw. Well, I'd put my XYZ into roll pitch yaw, or roll yaw pitch roll. And they were just simply in the wrong spot. So then I swapped them around and put them in this order down here. So now when I run it, I can see that the transform that comes up says, yes, the X offset is 0.67 meters. And I haven't run it after I've done that. I thought about getting up early this morning, but I didn't do that. So then so yesterday I went out and drove. This is the data before I fixed that static transform, and just going through these. So the first one is, again, it's my GPS 0 directly off the GPS receiver. So I got my GPS 0, that's the back antenna. GPS 1 is the front antenna. So again, you can see the blue comes around, and the blue this is the back. So there's the back of the robot's going like this, and the red line is the front of the thing as it comes up and goes to turn. You can see the front of the vehicle's out, and then it turns, and essentially the back end just follows like a trailer. It follows along whatever the front's doing, and that's why those two don't line up. And then the other one, again, like we saw in the last plot where it said GPS filtered, I think that's an actual output of the whole thing, and that's the green line. And let's see, I can't zoom anymore here because of what Slack has done to me now, but looking over here, it looks like the green line is smoother, and the back GPS is kind of bouncing around a little bit. So that's just simply, again, for reference, this shows as I drive, I just started the yard here and drove in a circle, and then drove in a square, and then stopped. And then over here on the right, this is the GPS ODOM program, and I've modified mine. So each copy of GPS ODOM puts out two values. It puts out the original translated, where it takes latitude, longitude, and translates it into my XY offset. And then it puts out a second one where I've remapped it so it thinks it should be on top of baselink. So this is saying the orange one here is the back antenna, and then the pink one is the remapped one that they're supposed to be. It's supposed to be on top of baselink. And it's not. It's fairly close. And then down here, I think the purple one, I can see by the way it's driving over. The purple one is the front antenna, and then the bluish one is the front antenna mapped on top of baselink. At least that's what it's trying to do. And I say I don't have any dots on here. It's interesting to watch because as you drive it around, you can actually see, like for instance, right here, I'd start up. This is the back antenna, so I'd have a dot right there, and here's the front antenna. I'd have a dot there. So as you grab the scroll bar at the bottom and start moving along, you can see those pairs of dots moving along here. And what I get is I get a cluster of 3 dots that's following the back antenna, because it's the back antenna, and then the back one and the front antenna both mapped on top of baselink. So those just form a little cluster of 3 dots, and then a single dot out in front as you drive around. So as you move around, you can see those dots. And maybe that's, I don't have it on that one either.
What's the jerkiness going on at
up front here, like right here?
Yeah.
That's simply because my GPS apparently hadn't locked on. I need to modify my stuff because I can't see my status until I actually start my main launch file, and then my status lights will show up, and then I know if I have a GPS fix or not. And I need to separate those out so I can say start it up and start up the driver, for the GPS receivers and start up the driver for my status strip. So before I start everything else up, I can sit and watch the GPS and decide when it's actually publishing, when it's locked on, because otherwise I get this garbage showing up here as it's kind of wiggling around, and then all of a sudden is this one we're just looking at?
So that's just the movement associated with pre-RTK and then getting RTK.
Yeah, so technically I think I started here I parked it in the yard, and here's the two antennas, and they say, okay, I'm right here, and then they start wandering around as it's coming up, then all of a sudden, bang, it jumps over here. So it probably went here from a single point, jumped over here to a float solution, it kind of wanders around, then all of a sudden, bang, it got a fix, so it jumps here. So this right here and this right here are the final points before I start moving. That I've now got a valid fix at that point.
Got it.
And this might be important right here. I think that, what did I say? The orange line was, orange line's the back antenna, and this is the bluish one is the front antenna remapped. Those technically, no, this is actually showing something I hadn't realized before. So right here, when it starts up, the front antenna is right here, and that's directly off the antenna. It says that's its based on latitude and longitude. It's right there. And then the orange one is the back antenna there. And then both the front one and the back one are remapped on top of baselink. So both of those are right on top of each other. So that right there, that very first thing that started up, that's actually right. So here's the back antenna, and then it's remapped on baselink. Here's the front antenna, it's remapped on baselink. So there's my 4 points where they're supposed to be. And once I start moving, I think they start doing funny things to me, but right there, that's a good example of showing that the remapping is actually working at that point. So then we move on to the next image. And this is, again, like I showed on the other plot, this is the odometry filter and odometry GPS. So I think the one called GPS is essentially the one that's converted latitude and longitude. And so that's the XY offset of meters. And then what's called odometry filtered, I think it's coming out of the EKF. And again, you can see that if I could zoom in here, you can see that the blue one is a smoother line than the green one. So that maybe is doing what it's supposed to do. And this was just another drive around to prove that it's actually doing something. And then over here was, so I took the odometry filtered, which I think is the output of the EKF, and I plotted that directly against the back antenna location. So you can see here that technically they should be off by 8 centimeters while I'm driving around, and maybe that's what I'm seeing over here. But I notice when I'm driving horizontally, the two seem to line up, and then anytime I'm driving vertically, I've got this offset between the ones here. And I later decided that might be because my static transforms are screwed up and I've got the wrong values in. So I want to see if this goes away when I take it out and drive it some more. So this is technically, if everything was working right, I could have plotted the filtered odometry, the output of the EKF. I could have plotted on top of my ODOM 2, which is the back antenna mapped on top of baselink. And then if everything's working right, those two should be right on top of each other as they drive around. And right now it's going to the back antenna. I don't know if that's a problem. But anyway, again, this was my second attempt to do anything. And let's see, let's go to this one.
Did I hear you say there's 80 millimeters between?
There's 8 centimeters from the back antenna to baselink. So the antenna is 8 centimeters behind baselink mounted in the back. And so as I said before, some of the things I was trying to prove was, I don't know if those pictures are the way, I don't know if these pictures get moved on the video. We'll see what happens here. Let's hope the pictures aren't on the way. So anyway, I solved the problem of the origin in the front yard. You can put on a parameter that says parameter datum, and you say latitude, longitude, altitude, and then it picks that up and then uses that as the starting point. So number one, it did set my origin where I want it in the front yard, and number two, it solved the weird rotation that I had, so that that seems to have solved both of those problems that I was talking about before. Now, the other thing on here, I was saying that, well, when I drive horizontally, they're pretty much lined up. When I'm driving vertically, they've got this offset. This is just a zoomed in version of that, so you can see better that's what that's doing. So again, as I'm going horizontal, they line up. Down here, as I go horizontal, they line up, and then anywhere vertical, I've got that offset between the two. So basically, that's just the point I'm at right now, that after 2 successful runs out in the front yard, that's the kind of data I was getting. Let's see, I think that's all the pictures I wanted to show on that. Where am I at right now? What's this do? There we go. Yeah, and then here's an explanation on here of what I was doing with these different images down here. So at this point, I've fixed my static transforms. So I'll go out today and drive it around again, and then see if that affects the offsets on the stuff. And then I also kept thinking I'd like to speed up my GPS publish rate. Right now it's putting out 5 hertz output. So last night in the middle of the night, I was digging through PDF files, and I found one that said if I run, I can actually run all 4 satellite constellations, which would be GPS, GLONASS, Galileo, and Beidou. And if I do that, I can set it to 8 hertz rate without doing anything special. So I could just go from 5 hertz to 8 hertz and get a faster rate. But I thought, well, I want to go all the way to 10 hertz. And then based on that, I thought I could pull up that table and show you here, but it'd probably take too long to do that. It says if you drop down to, I think it's 3 constellations, and you just want RTK. So if I throw out the Beidou, I think I can then get 10 hertz output rate. And then if I drop down to just GPS, what was it? If I drop down to just GPS with one other constellation, whichever one it is, then I can set it to 15 hertz. And if I select just GPS satellites only, I can run it at 20 hertz. So that I've got several options there on how I can configure this and get my faster output rate. And let's see, how do I stop sharing? And but then a page down below, it says, oh, if you're running moving baseline, my options are more limited. It says I can either run at, I think it's 8 hertz with several different configurations, or if I run GPS with any other constellation, so I just run in 2 satellite constellations, then I can run 10 hertz on the moving baseline. So it looks like putting those 2 together, 10 hertz is what I'm gonna shoot for. So I'll go through and configure the thing for either GPS and GLONASS or GPS and Galileo, and then set the output to 10 hertz and see if that still works. And they're claiming no matter what I set that at on moving baseline, it says I always get a 0.4 degree accuracy on my heading, no matter what I set that, no matter what speed or number of satellites or whatever. So it thinks it's pretty happy about the whole thing.
Do you happen to also keep that GPS odom.py program running to calculate odom while you were doing the odom filtered process?
Yes, I did. That was this plot. That's this plot right here. So that's it's 2
the
copies.
3 and 4.
It's 2 copies of my odom pi. So the 0 and the 1 are off the first copy, and the 3 and the 4 are off the second copy. So
I didn't understand that. So the second copy is GPS odom.py.
The second copy is connected to the front antenna. The first copy is connected to the back antenna. So I've got GPS odom pi running, and I modified mine. So my program puts out 2 outputs. Puts out the original GPS location converted, and then it puts out that position with the offset subtracted off to try to map it on top of baseline. So I've got 1 copy running connected to the back antenna, and that's what the orange and the pink line are. And then I've got a second copy of GPS odom running, and it's connected to the front antenna. So the purple and the purple line and the blue line here are the purple line is where the front antenna actually is, and this blue line is that antenna mapped on top of baselink. So like in your case, you would just have one copy running because you don't have two antennas, two receivers running. And theoretically, we could still get, it would tell you, like it does now, it'll tell you where your actual XY location of your antenna is. And if we add in the code that says remap that to baselink, then like here in this case where it shows the purple line and the blue line, see that it moves the purple line on top of baselink is what it's supposed to be doing there. So yes, and the first time I ran it, I didn't have this running, so I didn't have a reference. And then, like I said on this plot, this is the let's see, ODOM 1. So was that 0 and 1 or is that 1 and 2? It was 0 and 1. So actually, this I think is, let me back up. So the back antenna, ODOM 1 is the remapped one. So that's the one that says it's the back antenna, but it's remapped on top of baselink. So that's what ODOM 1 is. So the pink line here is the back antenna supposedly mapped 8 centimeters on top of baselink. And then the purple line is the front antenna, and then it's mapped onto the blue line, which is 0.67 meters or what, 67 centimeters apart. It's telling me my
Let me
internet.
ask it this way.
I just want to point out, it just popped up that my internet connection is unstable, so I might have breakup problems here.
Yeah, it stuttered just a little bit. Let me ask it this way. So Mat Sadowski, he produces an ODOM statement, right? Out of his process?
Yes.
Are all 4 of those on that plot on the right coming out of Mat Sadowski's ODOM process?
No, these have nothing to do with Mat Sadowski's code. This is the stuff I was running before I tried putting his stuff in. So it's just, as a reference, I'm saying, show me where my antennas are and show me those remapped baselink. So this has nothing to do with with Mat Sadowski's navsat transform and robot localization. This is directly off the antennas and plotted.
Where I was going is I was curious about comparing the output of his Mat Sadowski's ODOM statement with the output of GPS ODOM.py that, as an example, I've been using.
And that's what this plot is. So this plot is the output of the Mat Sadowski stuff that says odometry filtered. That's the red line coming around here. And then the green line is my back antenna mapped on top of baselink using GPS ODOM. So yeah, that's exactly what this is doing. And that's why I fired up the GPS ODOM stuff again. So I have, I've got, several different references here now I can compare back and forth. So that ideally I want these on top of each other, but they're not on top of each other. In fact, this next one. See, again, this is what I was saying, that they're not exactly on top of each other, but it is, this GPS ODOM 1 is from Matt Droder's GPS ODOM.py, but I've remapped it to baselink, and the bottom one is the output of the Mat Sadowski. We got 2 Mats here. We got Mat squared today. This is the output of Mat Sadowski's code that I think is the output of the filter, output of the EKF. And I plotted both of those on top of each other. And they're fairly close, but I've got some kind of a weird offset. And that's why I'm going to run it again today and see if I fix that. And if not, then I'll have to do some other playing around to get that to work. So yes, I've directly compared the original stuff that everybody has been running to this new navsat transform and robot localization EKF. So this is the direct output of those 2. And if I zoom in here, I could tell you how far apart that is, but those are a tenth of a meter. So I'm off by about a tenth of a meter as in that one direction for whatever reason. I just need to track that down.
And you're thinking at the moment it's probably explainable.
I'm hoping it is. I'm hoping that's explainable. And then there's all these weird things about that you have the frequency of the loop rates of how often it updates stuff, and the fact that my GPS is publishing at 5 hertz, and my I was gonna mention my IMU, but my IMUs, I'm not using the IMU at all right now. I've just got Another weird thing that popped up, which I don't have a plot of that. So Mat Sadowski said he was using the uBlox output message called nav heading. And somewhere, if you dig through the documentation and dig through the source code, it says that is a quaternion that takes the some internal heading from the GPS stuff and publishes a quaternion that gives you your heading. And I think I had to dig through the source code to find out that that's actually an E and U format. And the other, if I pull it directly off my static baseline, that's an NED format. So I directly have two different things going on there. But when the two points, when I looked at his stuff, he was only running one copy of a GPS driver, of the uBlox GPS driver. And when I run mine, I run two copies. I have a copy for each board that I'm using. And there's funny things there. So if he just simply said he's using nav heading, that was probably coming off the one that's not his dual baseline. So it could be that, I can get a better result out of that. And the other thing I noticed was when I went and plotted this, they said this is converted to E and U format. So technically, if I'm pointed north, my E and U should say that I'm at plus 90 degrees, I believe. But I go plot that out and it says I'm actually at minus 90 degrees. So there's like 180 degree offset from what's there. And I don't know, either I'm misinterpreting that or they screwed up, when they created that, they got the wrong number and nobody noticed. So there might be something funny about that too. And actually, I think if I plot those and look at them, I was thinking that the nav heading is noisier than the actual static baseline output. And so they might be generating that in a different way. So there's more things that I can look at and see if I can figure out, which heading I should be using or whatever. And another option would be to take an IMU and put into this instead of trying to derive a heading from the GPS. So like in your case, you could probably put the B&O 85 topic directly into this for the heading and get that to work. But I was thinking, I was plotting your B&O 85 heading against your GPS heading, and I didn't think it was quite as close as you'd want it to be. So that's just one more thing to consider. You have to look at all these different things, and that's why it's handy to be able to get, like in this case where I'm saying I'm plotting the old GPS ODOM against the new NavSat transform stuff. And so that way it gives me two references and I can plot them on top of each other and decide, one of them is wrong and I'm not sure which one. So that's a way to do that. So it's same with a heading. If you plot your, anything that generates a heading, plot all those on top of each other and see how closely they're tracking. So that's just one more. For a debug step, it's good to have all, several sources of all this information, and then you can plot them and compare them and see which ones look right or look better or whatever. Or if they're going in the wrong direction, the wrong direction, or they should be minus 90 as opposed to plus 90. You can see things like that fairly quickly on the plots.
I'm trying to remember. Did Mat Sadowski's stuff require IMU input?
No, his whole point was he wanted to do this with just the GPS.
Yeah,
and that was his statement. He wanted to show that you could do that or show the simplest form or something. So he's actually getting a heading out of his GPS stuff. And I'm not sure that what he was reading up was actually the correct heading, or because he's got a dual antenna system where it's got the little board stacked on top of the big board. But I decided I had to run two ROS drivers in order to get that data out. He's only running one ROS driver. So when he says he subscribes to nav heading, he's probably getting the non-dual baseline one, which is good because that means it's working even without. So essentially what he was running, I don't think it was using the dual baseline static heading. It was just essentially using what you would have, which is a single receiver.
That requires you to be moving.
Yes, but if you're not moving, it knows you're not moving and doesn't do any updates, I believe. So I don't know what we'd have to. No, one more point. The nav heading that he's using, I think, is already clipped inside of the driver where it does not give you all that garbage when you're not moving. So again, there's little details you'd have to figure out what does it really want, and then how do you manipulate it to make it do that.
Yeah, I should look through my GPS reference manual to see how to clip mine, because my China GPS doesn't clip.
I'd have to dig through some of those outputs to see what you have there. It could be that something will actually do that. And I actually wrote a node that will take the output of that /GPS/velocity message and break that down into a heading and break it down into forward speed. And then based on that, I said, okay, if the forward speed's below a certain number. So I've got a node that takes that one topic in and generates a heading and a speed. And I think I generated rotational velocity off that. And the speed is then clipped. So if it's below a certain point, it doesn't, it just latches that. So I do have that
on speed too.
I do have it available that, should work on any standard driver, except now the people that wrote the uBlox driver said, oh, well, we're going to convert that to E and U format because that's what Ross wants to see. And I don't believe the NEMA navsat driver does that. So it might be handy to have a parameter that says convert that or not, just because of all the stuff they've introduced and could be a problem.
Next thing you're going to do is you're going to tell me you're going to rewrite the teleop driver.
No, because I don't use that. Is the main reason.
Just
I'm
teasing.
That's the reason I'm not going to do it. Well, if I'm at a point where something isn't doing what I want, I won't hesitate to hack on it to fix it. Or since in 2012 at the first ROSCON, where not Heather, what was her name? Whatever her name is, she stood up and talked about the ROS wiki. Says, don't write another teleop program. There are currently 3,000 teleop programs, and this was in 2012. So there's probably 30,000 different ones now.
That's why I said it, because I knew I would get a reaction.
Yeah. Oh, one other point was, so I said that I was looking at that. I think it was the nav heading output, and I think it's off by 180 degrees. So if I'm pointed north, I think it should say plus 90 as any E and U number, but it's actually saying minus 90. And I thought, well, I could just go in the code and hack it. But also occurs to me, I haven't updated that for a long time. It could be somebody's caught that and fixed it. So one of the things I should do is just update that software and see if somebody's fixed it. Or I could go, I found where that is in the code a while back. So I could actually go find out what they're saying there that they did to fix that. And either, so it'll be quick enough for me to try. I can just go in there and patch that line and change it to what I want and recompile that. And then, see if that makes a difference. And I don't know if that's really a difference, a problem or not. So just one more thing to think about.
And so based on the time you've spent on the Mat Sadowski code, do you see any inherent benefit of using that versus what I'll call the legacy GPS odom.py code?
The first main advantage is that lots of people are using it and lots of people are supporting it. Now, the other advantage might be that it may automatically be remapping the GPS antenna on top of Baselink. And the reason I say it might be doing that, when I was trying to figure out how to do it, I found an issue against that software. And it's actually one of the developers raised the issue and said, oh, by the way, we're not mapping them on top of Baselink. And he listed several things, saying, here's what we could do. And one of them was similar to what I was saying we could do. And he said, he had several messages. He says, it probably makes the most sense to do it right in this code to do that. And then it went down the line, and finally at the bottom it says, oh, this pull request should fix that. And then he marked it as closed. But on GitHub, I can't find any way to equate when he said he closed that or he said there is a pull request. I don't know how to go track that down to see what code he changed to make that work. So what was my point on that? So anyway, I think that program might actually do that for you. And and I looked at mine and thought, well, I can't tell if it's remapping, but that's when I realized my static transforms aren't right. So this will answer that question today. It could be that just dropping that in there, you've got an off-the-shelf piece of software that everybody supports, and I think it will give you the same thing that GPS ODOM has given us. Plus, I think it might actually remap your GPS antenna. In fact, it could be GPS ODOM. The output of that would be remapped. It could be I just had my static transform screwed up this whole time. So maybe if I go run that again, maybe that'll change that too. So we'll see what happens.
And mentioning the transforms, I think in GPS odom.py, the transforms are actually buried inside of the Python script. The
static transforms they're not used at all in GPS ODOM. It takes in a heading, it just passes that through to the output odometry message and the output transform, and it just converts the GPS into an XY, and it never looks at that transform between your antenna and baselink. And that's why I was trying to add that in there.
Okay.
And theoretically, you could write an external node that would do that. It would just simply take what it found and then do the offset, and then create a new resulting odometry message. It might be another way to fix that. But so until I go out and run this today, I won't know if I fixed anything or created new problems. So that's where I'm at right now.
Well, it's sounding like a more certainly from a supported standpoint, a more robust solution.
And let me go back. I said I was going to post the link to this. Let's see if it's in here. Otherwise, if I have to search for it, I'll never find it. Here we go. Here's the do this. Copy link. And then chat. I got to get back to Zoom somehow. Let's see. Stop sharing. Zoom chat. It looks like it gave me one link of the two. That's why it only gave me it says RG simple ROS integration. I was going to say we could continue on. Now let me do this before I forget. Copy link. Paste. So I put the two links for that in the chat. So theoretically, those will then show up on the video. So we keep talking about Mat Sadowski's code, and technically, Mat Sadowski's code is really just he took the standard tutorials and he just because the two nodes that he uses are standard nodes, and when I went to load those, it said they're already loaded and up to date on my computer. So basically, he just created a launch file, and then he created a YAML file for a configuration file for navsat transform, and he created a config file for robot localization. And they're essentially, right out of the tutorials. So I don't think he's got any real extra code. It's just the fact that he went through the steps and documented how to do this stuff. And one more thing, I should look at that. What's that other thing he has? That plotting program is called MapViz. It looks like that'd be real handy to figure out how to use that too. I know there's one called Satellite Viz or something, so maybe that's a plugin for RViz. And then this MapViz, I think it looks like it might be a different program, but it lets you put a map on the screen and then select topics, and it plots on top of it. So that'd probably be another handy thing to have.
Yeah, I've tried to make that work before, and that I got to a point where there was an error about an offset and never could work my way through that. So maybe that's progressed since the last time I tried to fight with it.
A couple more points. When I, in order to specify my origin, let's see how long it would take me to find this. If I say wiki for that. Yeah, but I'm not going to go down that path. It's fighting with me. What was I saying? And oh, so in order to specify my origin, you can say you have to go into the parameters for, I think it's the navsat transform. It's one of the two nodes. You have to go into the parameters, and you have to say wait for initial datum, and that's basically the datum is telling you your X, Y, Z location. And if you say don't wait for it, that's where that first plot I put up, it said, okay, it took my starting point in my yard and just automatically grabbed that and latched it in. And that's why my plots were rotated. So if you say wait for a datum, then you can either say, you can specify a parameter that says, you say parameter equals latitude, longitude, altitude, and then it said something like base link and ODOM and publish rate and some other things. So I did that like they said, and when I ran it, it said, oh, this is deprecated. We only look at the first 3 fields of that now. So right on the tutorial from ClearPath, where they're telling you how to run all this, they say put in this datum equals that. And so that is wrong and nobody's updated that. So when you go to run it, it comes up and says, oh, by the way, we're ignoring the rest of that junk on there that I didn't know what to put in for it or for is correct. So apparently you just have to put in latitude, longitude, and altitude into that. So what happens is you say wait for datum and then you put that parameter. So when it starts up, it loads in your origin and the you've specified your latitude, longitude, and I guess head, or no, it was latitude, longitude, and heading, I think is what you put in. And so by doing it that way, it takes whatever you put in there and that sets your origin. So it's basically like in GPS ODOM, there's a couple lines, one that says latitude origin and longitude origin. You put numbers in there. This is doing the same thing as that. So that locks those two together. And so the other option you have on that before I move on, if you say wait for datum and you don't supply the parameter, then they say you've got a service where later you can come and say, send this data to that node. So give it the current latitude, longitude, and heading. So if you wanted to, you could programmatically come up with that value and then just shove it in. Once the thing started, then you execute that and it loads that in. So you could do that rather than hard coding it into a parameter. So that's another way around that.
These are parameters in YAML files in Arduino simple rover configs.
I put this into it's either in the launch file or it's in the config file. I think it was in the launch file is where I put it. So if you look at the launch file, he'll say something like, and again, I can't have a quick way to pull that up here, but in launch file, it says start up the robot localization node, and then it says start up the navsat transform node, and you got some parameters right there. I just added in there. I said he's got the one line that says wait for initial datum. Yeah, right there. So down at the bottom there it says param name, wait for datum, value is false. I changed that to a true, and then added a line that said, I don't recall what it said. I pulled the line out of the ClearPath tutorial on how to run this, and it basically says something like, I think it says ROS param equals, and then it said latitude, longitude, heading, and then it had a bunch of other stuff that you don't need anymore. And so you just put them right there together, and that does it for you.
Cool. Well, you're really blazing a trail with Mat Sadowski's
interpretation.
ODOM derived from GPS only signal.
That's his interpretation of this GPS with ROS robot localization. So I guess my next step is go out and drive it and see if I solved my problems, and if not, then I can dig into, plot my things against each other and say, well, they're not correct. Why is that? And then try to figure that out.
And did you remember this because of the construct navigation in an outdoor setting Saturday session. Is that where you remembered this from?
No, I stumbled on this. I don't remember how I found this, but it popped up. I think I was probably looking for something on the F9P receiver, and I ran across his blog, and I remembered that he had written something on it. I didn't realize that's what it was doing. So that's where I found that. I know there's at least two different things on the construct talking about GPS on using GPS for localization. And I found with the construct, I find it very tedious. I find his, it's either his accent or the fact that he's not a native English speaker for me is hard to follow. And he's always making these cute little jokes that really don't make any sense. And then their whole point is they're trying to show you the steps to run their simulator, because their whole company is their simulator. And it's not really a tutorial telling you why this stuff works. He says, well, load this and then tie these names together and look at that on the screen. It's driving around the way it's supposed to. And that is very beneficial if you're trying to get the pieces set up, how do you connect it together? That's great, but it doesn't necessarily explain to you how it works or why it works. And that's why you have to look at multiple sources to find all this stuff. So in general, the other thing about the construct is every time they start up, the first 15 minutes are spent trying to explain to everybody how to start the stuff, and here's the errors they're getting. So again, you have to figure out, where in the code does he actually start doing some real work. So that I usually don't sit and watch those, but the more I learn about this, then if I go back and watch it, I say, oh, okay, I know why he's saying that. And then there's the other thing, from ROSCON 2015, where the guy, Tom Moore, who did a lot of the stuff or supports it, did a ROSCON talk on, telling you what it is and kind of, again, if you already know how it works, it made a lot of sense, but I'm still at the point where I don't know exactly how it works. So that doesn't make complete sense to me. So if you take that and then go to the ClearPath page where he also wrote all the stuff or supports all the stuff, and you put enough of this stuff together, I think it'll eventually sink into the point where I can say, if you do this and this and this, it might work. And then if it doesn't work, then we can figure out why.
Yeah, it's, I think there are very few master ROS programmers, and having somebody guide you through it once is golden.
As I look through the source code, I think, boy, it'd be handy if somebody would just say, let's look at the source code and go through the different modules and tell you why it's doing that and why it's there and what happens when, and as opposed to having 26 pages of undocumented code, and you just think, well, how does this stuff work? And it might work like this. And it says, if you've got this system or this system or this system, and so it acts differently depending on how it's configured. So that would be very handy to have. But back to your question, you said, how is this better than just using GPS ODOM? Well, it's the fact that you can also now expand it out. If you wanted to, you could feed in wheel odometry, you can feed in IMU and merge all that stuff together. So this is the standard path that everybody says you're supposed to do it this way. And the GPS ODOM was just a quick way to feed GPS directly in and make it work. And it looks like this is now proving that you can take the navsat transform and the EKF node, the robot localization EKF, and make it do the same thing, possibly with a more filtered output. You might be able to run this without the robot localization at all. Just take the value out of navsat transform and it'll work just like GPS ODOM. But I'll soon be at the point where I can either determine that or prove that. So it could be you don't even have to run the EKF stuff if you don't want to, but I think it will be an advantage to smoothing out the path. And then theoretically, you should get to the point where if you feed in wheel odometry and IMU and GPS, and if you lose GPS, it should continue on by using the other devices and do all this automatically. And I won't know until I try it how well it actually works. I think that's the theory behind it.
Yeah, I mean, even though you've got RTK, having it smoothed still feels like an advantage.
It does. And then when I was digging through the configuration files, there's because everybody kept saying tuning the EKF. And I thought, well, at this point, there's been no tuning at all done on it. You just load it up and say go, and it's giving some reasonable, what I think are reasonable results. But there's all kinds of stuff you can go in and modify with the covariance, how much it likes the covariance, and you've got just, you start digging into it. There's all kinds of stuff under the hood that you could play with if you know what you're doing. And I don't know what any of that stuff is, so that's another thing. If it's doing something weird, you can go search the internet, and on Ross Answers, somebody say, well, I'm trying to run this and it's acting like this. And then they might take you through the steps on how to figure out what that is, or at least explain what's going on there. So it's, just, again, it's an iterative process trying to figure all this stuff out.
Cool.
And as I said before, I want to try speeding up my GPS output. So it'll give me twice the number of points in the distance I'm going. And hopefully that'll make it smoother, and I'll see what that does. And I'll just see if changing that static transform broadcaster fixes any of my problems. And beyond that, I'll just say, compare my outputs. If they're not correct, then I'll try to figure out what to do about them.
Well, it looks like I'm getting an instant message from, I don't know if it's a politician in Minneapolis or the police department. It says here. Should
we stop the recording before you say anything stupid?
Okay. It was just going to be a joke.
Well,
but I'll stop the recording.
I have nothing else to say.